Okay, picking up here. A solution contains both sodium iodide and sodium bromide. Which oxidizing agent could you add to the solution to selectively oxidize iodide, but not oxidize bromide? And we're given some different choices here. So the first thing I'm going to do is I'm going to find iodide and bromide on our half reaction list here. And those are oxidations, so they're written backwards of what we see on this chart. So there's the reduction for iodide and the reduction for, reduction for bromine and reduction for iodine. Okay, so we're looking at the reverse reactions for those. And then let's identify where the other ones are. So here's Cl2 and H2O2 is way up here. CuCl2, we're not going to find anything that has copper and chlorine in it. This is a soluble ionic compound. The chlorine is just a counter ion. So this is just going to be Cu2+. So there's Cu2+, and there's another one. Could be either of those, we're not sure. And then nitric acid. Whoops. So this is the one for nitric acid. Okay, so how do we even think about this? Personally, I would rather have the numbers here and do the calculation and figure it out that way, but this is a conceptual question. Do we understand the concept? So the yellow ones are oxidation. That means that these guys are going to be backward, right? Maybe reverse is better, I don't know. Those are backward, and the other ones would be forwards. Did I talk about moving a desk on Tuesday? No? Okay. So one way to think about this is, you and a friend are moving a desk, and you have to take it through the doorway, and so you got one person on each end of the desk, and somebody has to walk backwards, right? Would you rather be the person walking forwards or backwards? Forwards is nicer, right? Because you're not going to bump into anything. You can see where you're going. So we can apply that idea to this. So this is a list of who gets to choose first, okay? So kind of like the FA 765 or the activity series, who gets to choose first? So whoever's on top gets to go forward, and whoever is underneath has to go backwards. So that means that H2O2 will spontaneously react with Br-. It will also spontaneously react with I-. It'll react with any of these in the reverse direction, right? So what we want here is something that's going to oxidize iodide, but not bromide. So if we want to oxidize iodide, that means that iodide is being the backward one. It has to be something above, right? So that rules out the copper, because copper is below. So copper will not oxidize iodide. The other three things will. But will chlorine oxidize bromide also? Yeah. It'll do both of them. And the peroxide, hydrogen peroxide, will also oxidize bromide and iodide. So those aren't the ones we want. We want this one, the nitric acid, because it's above iodide, the one we want it to react with, and it's below bromide, the one we don't want it to react with. that kind of make sense? Most acids will dissolve metals, and the way they do that is they reduce hydrogen ions into hydrogen gas with the corresponding oxidation of the metal to the ion. So you get the solid metal, becomes an ion that's soluble, and so it dissolves. So here we have the half reaction of hydrogen ion being reduced, and here we have zinc metal being oxidized. This is a picture of that occurring. And so we see the zinc strip in here, it's in hydrochloric acid, and these little bubbles that are forming are hydrogen gas. And those are forming as the zinc slowly turns into zinc ions, and if we wait long enough, the solution is going to look like water. All the zinc will disappear. It's still there, but it's not an element anymore, it's an ion. So metals whose half reactions are listed below the reduction of hydrogen ion will dissolve in acid. So if we look on our table here, we don't see the hydrogen ion reduction because it's on the next part of the table. The hydrogen ion reduction is the standard hydrogen electrode. So this guy right here has a standard potential of 0 because it was defined that way. That's what we use as the reference point. So that will react with any metal that's underneath, right? Because this one's going to go forwards, and that one's reversed. So this one has to be above that one, and we'll get a spontaneous reaction. There's one acid that can oxidize metals like copper that are not dissolved or oxidized by other acids. And it does this through a different half reaction. Instead of the hydrogens being reduced, we actually have the nitrogen in the nitrate that's being reduced. So here, let's just think about its oxidation state. The oxidation state of nitrogen here. Well, we have 3 oxygens, so those are each -2. So that's a total of -6 from the oxygen. And overall, we have to have -1. That means that the nitrogen has an oxidation state of +5 there. Over here, we have no, the oxygen's -2, the nitrogen is +2. So we see that the oxidation state of nitrogen is being reduced from +5 to +2. This has a cell potential of 0.96 volts, which is much higher than H+. So nitric acid will dissolve a lot of things that other acids will not dissolve. So here, this is asking which metal dissolves in nitric acid but not in HCl. So find our acids here. Where did you go? There it is. There's nitric acid. And the reaction that happens with HCl is not shown here. That's what most acids do. Nitric acid, the nitrate can actually be reduced. So then let's look at where are iron, gold, and silver. Here's silver. And there's gold. I'm having a hard time finding iron. It's under silver. Thank you. Well, no. See, this is not the right one. That's iron, but it's not Fe. It's Fe2 plus. So we're looking for Fe solid. Which is just not, it's not on there. Well, we've got F2, but I want Fe. So I did this yesterday. What's wrong with me? Well, this is the top half of the table. If it's not in the top half, where is it? It must be in the bottom half. So it must be below this. I don't know why I don't remember this happening yesterday. I'm losing my mind. It's been a really long process. Okay. So the iron is under this one. So we're looking at the orange ones being forward and the green ones being backwards. How do we know which is which? Well, here we're dissolving the metal. We're not oxidizing the ions. We're not reducing the ions. We're starting with the solid metal. So the solid metal is the product shown here, right? So this one, we're looking at the backward version of that and the backward version of this one and the backward version of the one that's on the next page. So we don't need to think about iron. Iron's not the answer. So we want to know which one will dissolve in nitric acid, but not in hydrochloric acid. So for these backward ones to react, they have to be paired with a forward one that's above them, right? So is gold going to dissolve in either of these acids? No. That's one of the really great things about gold. It's very unreactive. It just doesn't react with much of anything. What about silver? Here, silver is lower than nitric acid. So the nitric acid will dissolve this. This is the forward and the backward is below. Will silver dissolve in just any old acid? No, because it's higher. So let's do this, because we just figured out that it is silver. So we're looking for, it dissolves in HNO3. So the HNO3 is the forward reaction. And the silver is the backwards reaction. This side is nitric acid. That side is not nitric acid. This side is silver. That side is silver ion, which is not the same. So these are the two half reactions we're looking at, and this will be spontaneous if the one in the forward direction is higher than the one in the reverse direction. And that is the case. The nitric acid one in the forward direction is above. So this would work because nitric acid wants to go forward and he gets priority, he gets to choose, and silver has to go backwards, and so these people are going to cooperate and the desk will go through the door. if we try to get gold to dissolve in nitric acid, here, gold is higher on the list. Gold's like, I'm not going backwards. This guy's below me. I get to go forwards, not him. And so it's not going to work. The desk is not going to get moved. So they're going to argue about it. That make sense?